All right, great. Well, thank you all for joining. This is today's meeting. Very much looking forward to it. We have these the third Tuesday of every month, and you can check on our website and see which one, see if they're ones you're interested in. This just clicking forward here. Huh, no, we're clicking forward before. Well, all right, I can do it that way. We're Passive House, California. PassiveHouseCal.org is how you can find us, and we are a part of the Passive House Network, which is that's in New York. PHN. Susie here is taking care of this for us. We are also members of International Passive House and the Passive House Institute. And we always start off by thanking our sponsors. So Southern California Edison is a gold sponsor. They do 3 or 4 webinars a year for us, as well as helping us with other things. Small Planet Supply and Earthbound Homes are our silver sponsors. And then where our supporting sponsors that we have go across, I'll just read across 475 High Performance Building Supply, Rockwool, which is an insulation, FGA, Fergus Garber Architects, Ream, which the hot water heaters, and Hayward Lumber Company. Pete Moffett Construction is in the Bay Area. And bills to Passive House, Steve Eltron, another water heater. CPHBA, which is Cyril's company. Good Space. Good Space is another builder. They're in the Bay Area, in the Sacramento area. Intelligent Membranes and Prosoco are two sources of things that are a part of making your air sealing and eliminating the thermal bridges or breaking thermal bridges. Icon Windows and Doors, and then Todd Jersey Architecture is our most recent person joining. So thank you for going through that. I'm going to now stop share, and so Susie, you'll be able to take over.
I can just start with introducing myself until Spencer gets himself unmuted. I'm Kristin Nichols. I'm a designer for Med Architecture. I've been with Med Architecture for 6 years, designing residential and small commercial spaces. And I'm also the designer of Windhorse Orchard.
And I'm Spencer Dobrovolny. I'm a general contractor out of Marin, and I focus on high performance building enclosures and comfort retrofits. Many of these people are on the call today, but I definitely wanted to acknowledge the team, and that it takes a village for sure of smart people to pull off a project like this. And also, I would like to encourage anybody that's sort of getting their feet wet into this world to reach out to any of these people and anybody else on the call. I've really just found from my experience that this is just a great community to lean on, and everybody's generally open to sharing and really invested in everyone else's success. So
yeah, so this is our project. This is my family home. We bought that a little less than 5 years ago. And I was just into architecture for 1 year, and I really wanted to learn about sustainability. So since the architects I was working for were wonderful, but they wouldn't give me big projects like that, I basically had to do that on my own house. I had to tear down the walls of my own house to really study how can you do it sustainably. So so when we bought this house, as you can see, it was a fixer-upper. Windows, siding, and roofing was at the end of their lives and needed replacement. But we were also thinking about, oh, how can we make it look cool? So we had these schemes of like drastically changing the shape of the roof, changing this octagonal tower to be square. But this is, by the way, this is my husband, this is me with our back then just 1-year-old daughter, who's a 5 today. So really quickly, we realized, hey, we have a limited budget. If we do want money for all these sustainable features that we were excited about, we need to be super minimalist in our scope of remodel. So we already we were looking into the Living Building Challenge and Passive House, and it felt like, oh yeah, these standards these are the standards that's going to provide the environmental features that we think are important. So why combining these standards? Well, we found the Living Building Challenge first. And what we really liked is that it was this super holistic framework, starting with place, water consumption, energy usage, health and happiness, materials, equity, and beauty. So there's a lot covered. What was not covered is being especially energy efficient. So we felt like basically Passive House is kind of this missing piece to build even better. And then maybe quickly one slide back from our house before to this is the design we came up with. Like we still did make changes to the shell. As you can see, we eliminated the eaves to make it look a little more contemporary. We brought down these south-facing windows all the way to the ground, and these 2 west-facing windows. We added 1 additional window. And this is, we decided to use metal roofing and siding. We are in a wildfire risk zone, so we really needed to be fireproof. So again, here the floor plan, this is just the downstairs. This is the before, this is the after. We eliminated a primary entrance to the house. We turned this existing breakfast nook into a mudroom and primary entrance. Our an existing dining room becomes a home office. An existing family room becomes a dining room. And an existing mudroom becomes a mechanical room.
What?
So as you see, relatively minimal changes. And we did not change anything on the upstairs. The bedrooms and bathrooms stayed as they were. So in order, it was quite a lengthy process to plan all the details of the Living Building Challenge and the Passive House. It took us actually 3 years, and then we had another baby, so we had to wait another year before we could start construction. So we did do some upgrades prior to starting our main construction to make our fixer-upper a little bit more livable over the last 4 years, because we were in the house most of the time. So this is our Passive House design concept. Since our remodel basically came down to a shell remodel, we would not open up walls from the inside, so it made kind of most sense to put our airtight layer on the outside of the sheathing of the walls and the roof. So we are using Solitex at Hero to membrane around the entire house. And then on the bottom of the floor joists, we install Intello and bring that down to the foundation to connect the airtight layer through the foundation. We are shading our south-facing windows 100% in the summer, and trying to allow 100% of window sun in. We are using triple pane windows, like the using better performing windows was kind of where we made the biggest changes to being more energy efficient. And we are adding exterior insulation on the walls and the roof.
So I wanted to talk about some of the takeaways that in general that I've found throughout the construction process. And most of them have to do with retrofits in general, but also when passive house and living building challenge get layered on top of the project. So first off, it's important to be ready to be surprised. There's going to be things that are unexpected that come up, even in the best laid plans beforehand. And during that time, when you come across something that you weren't expecting, especially from a builder standpoint, we so often can get into the mode of just production and get to the finish line. But you really have to slow down and rely on your team that you have in place to communicate and solve the challenges at hand. This first picture here expresses one of these challenges. It's a photo that I took that it's of the east elevation of the structure, and this is just after demo started. You can see we took off the T111 on the bottom, on the first floor there, and you'll see in the middle of the photo there's the white tubing coming down. That's the line set from the split system that's installed. The head is up in the attic, serving that second floor. So as Kristin mentioned, there were some upgrades done before we started construction, and they got off gas. They're incentivized to do so early, and they actually had the MEP contractor selected before I came on board, but I was able to consult on placement and stuff like that before they got started. However, they did their work before this demo began, so it's sort of like an out of sequence. In general, you would want to do demo framing and then bring the trades in, but this is the case that we find sometimes in retrofits where you sort of get out of sequence. And so we have existing mechanicals in our way, kind of, and we had the best laid plans to sort of avoid any structure that we knew was coming down the pipeline with this placement. But it just turned out when we got things opened up that, sure enough, structurally we wanted to replace that rim joist of the second floor system there with a solid beam. So now this line set is kind of right in our way. So eventually we were able to just kind of slow down at this point, communicate with our team, talk to the engineer, and figure out a solution so that we didn't have to go backwards and move some existing work around. You'll also see in this photo that I've marked up in green several locations. This is used as a tool to communicate. There was existing penetrations, holes, notches in all of the plates there. And again, just being able to communicate the existing, once you open something up, there's really no way that we could have known what we were looking at until we actually got in there. So here's another example of some of the challenges that we face. This one has to do with structure, changing structure in a retrofit, but also sort of was led by our passive house goals. I think early on, Graham suggested that we get rid of the existing crawl space hatch access that was inside of the living space and move it to outside of the envelope. And this is a great idea, especially for passive house, because these crawl space accesses are notoriously leaky and hard to seal well. So kind of getting that piece out of the way, out of your, thermal boundary and out of the air barrier layer makes a lot of sense. So you can see the hole below those, that French doors that leads to the office. It came up that this was sort of the best location on the house to try to make this change. But it also came with its challenges because it happened to be directly next to a hold down, and it was also a spot that was really close to a step in the stem wall. So again, it just sort of came down to getting things opened up, kind of seeing what we're dealing with, and then slowing down, communicating with everybody. In the end, I think we were able to just pack out that column for the hold down like 1.5 inches over, and then cut that step all the way out. You'll also notice in this photo there's a hole in the upper rim there that is part of the second floor framing system. So we're adding a beam into that member, sort of like reverse Jenga on a building. But so that can be technically challenging, just the carpentry involved in the placement of it. But also you run into these situations where in a retrofit, there's all this existing stuff in the way, mechanical, electrical, plumbing. In this case, I think there was 5 or 6 main circuits that ran through all of those floor joists, and they were drilled in a line sort of really close to the top plate of that first floor. So it's one thing actually getting the beam in there, but you have to untangle this web of existing electrical and then figure out how to put it back. We ended up having to change the course of most of those lines and figure it out. So, and then I'll also just touch base on this, the windows for this project. There weren't a whole lot of options, and by the time I came on board for the project, they were basically selected. We went with Cascadia, and there was a couple of details about their installation that I wanted to that caused some challenges for us in the field. Yeah, these challenges sort of are interrelated with the Living Building Challenge and Passive House goals, as well as the retrofit application. The installation hardware that Cascadia provides it for the windows, there's a sill, like an aluminum angle that gets installed into the rough opening first, and then it gets integrated into your sill pan, and then the up leg of that aluminum angle gets a wet bead of sealant that the window then gets pushed into. So basically you're creating this wet blind seal at this critical juncture in the window assembly, and it's like the only connection for the air barrier at that point. It's the last line of defense for water management. So first off, it sort of makes it a tricky install because we're used to installing these flangeless windows from the inside, but now we have this sort of bump or curb in the way. that we have to lift and maneuver over and kind of wrestle the window back in. But, you know, we sort of figured out that process, and by the last window install, we were experts at it. But beyond just the technical challenge of sort of working with that, also, that particular sealant, we couldn't find something in the ProClima line that we were using that would work for that spot. Luckily, through some research, Ian stepped up and found an off-brand, sort of off-the-shelf product that we could use that worked with both LBC and passive house requirements. So we were able to find something that worked. And sort of, I'll just briefly mention the no eaves thing was awesome aesthetic design, and it actually made things pretty straightforward from a like wrapping your layers perspective, easily stay continuous on your air barrier and our continuous insulation from wall to roof. But from a builder's perspective, you know, I like a deep overhang and a big eaves. I think it helps protect the structure. So certainly on this project, I was hyper vigilant about detailing of the openings and the windows and doors in particular. So.
Yeah, so yeah, we talk a lot about challenges in this presentation today, but we are hoping to inspire people to do the same, and we are hoping with like presenting our challenges, we might just provide a little bit of guidance how to solve these issues. I want to talk about how how following passive house actually also helps achieve the Living Building Challenge. So under the Living Building Challenge, we need to supply 105% of our energy demand through renewables on site. So of course, it makes sense to minimize those energy requirements in the first place. Then we also have air quality requirements under the LBC, like VOCs need to be under a certain level, carbon dioxide needs to be under a certain level, particulate matter needs to be under a certain level. So having a passive house that's just continuously aired out through a ventilation system is helpful. And then passive house can actually, using passive house standard can actually also lower your embodied carbon footprint. So that was my one interactive moment. I was hoping to hear back from you guys. What do you think? Why would passive house that might like rather increase the amount of materials that you use in a building than reduce the carbon footprint? So that might not be so obvious. So maybe yeah, you can think about that a little bit too, and I'm really curious to hear why that could be the case. And I'm not talking about operational carbon. I'm pretty sure that everybody in this room knows that passive houses obviously help to reduce carbon footprint from operational energy. So here again, some challenges when combining passive house and the Living Building Challenge. And to give you some background about the LBC material requirements, we need to source locally. We have these different contingent, like 20% need to come from within this radius here, and then another 30% from here. So we need to source relatively local. Then 90% of our materials by cost need to be register free. And we need to divert construction waste. For example, 95% of our insulation scraps can't go to the landfill. And then in the end, we need to build carbon neutral. So looking at these requirements, and then also that was also my biggest learning from this project is we need to use local organic materials as much as we possibly can. Why? Because they are often red list free. They are often certified compostable. And they are often carbon sequestering. So they can offset some of these, some of your high carbon contributors like metal and siding and roofing, if you have to use it like us, or triple pane windows. So here, here's one example for such an organic material that we used. That is our exterior insulation. It's wood fiber board. So of course, foam and rock wool were not options for us because of the toxic ingredients, because of the high embodied carbon footprint that these materials bring, but also because we simply couldn't have achieved 95% diversion rates for the insulation. Like I had a really hard time trying to divert my construction waste from the landfill, like asphalt shingles or fiberglass. So like dealing with these materials and like knowing, okay, all you can do is bring them to the landfill is so frustrating that it totally pushed us even more towards using organic materials. Because then what do you do with these scraps? This is my husband and my daughter again, and they are creating these landscape elements. So we dug holes and we just put this insulation material in there. And of course then wood fiber insulation board is also non-toxic, and it sequesters lots of carbon. So and that is I don't know how familiar you are with short-term sequestering benefits and long-term sequestering benefits. It's just something that I'm understanding more recently is the biggest sequestering impact that you can make is take something that would otherwise go into a waste stream. So take like these wood fiber particles that would otherwise really directly decompose, or take straw and like store it in your building and save the climate. So the one big challenge was especially the Gudex insulation was cost. We ended up paying $15 per square foot. And that is not just the material, but this is also all the extra effort that you have to do to get it installed and have it be ventilated. But there's space for optimization. We did that the first time, obviously. So one thing, for example, like you can see in this picture, we use all these traps because this is what our structural engineer said. Yeah, this is what you need to hold back the metal. But then my metal guys, they only use 25% of these straps. They only fasten their panels like every 4 feet. So there's ways to bring that cost down. Another challenge is passive houses are relatively heavy on mechanical equipment. You need that makeup air system. You need that ventilation system, and every new house needs a ventilation system now. But still, mechanical systems are usually not red list free, and it's extremely hard to find to get product declarations on what's in those materials. And here's already my last slide. And this is our house as it looks like right now. We are extremely happy with what we created. This house, when it's done, it's designed and built to last 80 years. Yeah, so I really hope that it can inspire other people to do the same and to use both these standards, the Living Building Challenge and Passive House, to make better buildings. And we would be so excited for you to reach out with questions or with feedback or anything you want to share.
We had one guess for why we were so low on carbon embodiment, and that was fewer solar panels. Was that close? Do you want to hear some more guesses?
Oh, did anybody else guess something?
Not yet. Anyone else want to throw an idea out there? It could be the wrong idea. Low carbon siding, less insulation from high air tightness. Was it the insulation itself?
I think so. So you need to foundation. So it's actually opposite. Since you need more material, since you often need more insulation, you have better reason to use organic. You have a reason to use more organic materials, and that wood fiber insulation brought 4 tons of carbon sequestering benefits to our project. So yeah, this less solar panels is also for sure also creating a lower carbon footprint.
Okay, so Daniel and King says that's what he meant. Yay! And then Christian, did you get your question answered?
I think the interesting question with the retrofits as a challenge which we have observed is a connection between the wall air membrane and the crawl space membrane, and especially how to get it below the existing foundation and the foundation stem wall. And what was your experience? What was the best detail? How to succeed with that detail and getting it airtight? And also, what is your airtight numbers you came in with the door blower test? But that detail is of special interest.
The detail how to connect
the exterior wall membrane, you know, the air and weather membrane, which comes down from the wall, and to connect it through the crawl space air tightness membrane, because you have the existing floor joist sitting on the stem wall, and you have a difficult time to get the membrane through it in an existing building. In a new building, it's easier, but in an existing building, that's a challenge in leaking detail. And how do you achieve to get that airtight? What was the best strategy? What worked, maybe, but which didn't work?
Yeah, so like when we first talked to back then Ashley and Spencer, these guys like said, oh, that's going to be the difficult part in your project, and maybe that's also something how we can get construction costs down if you guys do that yourself. So basically my husband was in charge of doing all the crawl space work. While of course on the exterior, it's really simple, right? You just bring down your membrane all the way to the foundation, and then we used like a special tape that connected that membrane to concrete. 475 is selling something especially for that purpose. And then in the crawl space, since we wanted to put a new insulation anyways, we stuffed these joists with sheep's wool, and then we stapled a membrane on the floor joists, and then we taped the seams of this membrane, and then we taped that membrane to the foundation. We did not even tape over the staple holes, which the blower door test came in with 0.6. So it was a lot of work, but it was hard on my husband. Like he spent like many hours down there in the crawl space, but I had fun because I never do physical work, and like sheep's wool it smells good. It is easy to touch. It's easy to install. So like we had to find out, okay, you need to put this thick pillow under your head to be super comfortable, and then we even had some couple time down there. We were like, oh my gosh, we are together, no kids here. So I can recommend it.
Nice.
Some crawl
so
space romance.
That's right. And Graham, did you have a question?
More of a comment related to that. I have very little guilt about the work that I do in terms of passive house design and detailing, but the crawl space stuff, I always like, oh, thank God that's not me doing this. So I'm happy to hear there were some joyous aspects to it because yeah, that's just tough.
It's not, no, I really am not exaggerating. It's like once the moisture barrier is the hardest, right? That's when you crawl in dirt. But like you do that, you put that down first, and then you slide there like in a clean space. It's really it's not bad.
Another question from the chat, with the merging of Passive House and LBC, which feature of each framework was the hardest? And are there any unresolved conflicts?
What was the hardest? Gosh, I want to keep my wood burning stove.
Mm.
And like mainly also because I just thought about it so much. How can I get this stove through this shell? But it's been hours and hours and hours and hours of work and it's not done. Like I'm taking it step by step. So I cannot recommend putting a wood burning stone in a passive house. But since we didn't have a heating system, we needed heat during before we started remodeling. We just needed that wood burning stove.
Mm.
And then for the living building challenge, it's certainly the red list free requirement. Like I'm at 89%, so I think I'm pretty good, but it's like constantly, oh my gosh, but I still need this mechanical system. So that hitting those 90% red list free materials is really difficult.
Mm-hmm. And there's a question about which windows you specified.
We use Cascadia, like was the reason that I would have loved to use a European window. I'm German, so of course, I mean, I trust in the quality of European products. But since we also had to get it from more local, Cascadia was basically the only option because also Cascadia was able to prove that they are red list free. There would have been Alpen, but Graham said no Alpen. So, and we trusted Graham. So,
Yeah. And there's a question now about how has the vacuum flush been working? Does it require a holding tank, maintenance?
oh, the vacuum flush toilet. So it works relatively well. It is just pumping it directly to the septic system. There's a dishwasher that's kind of pushing it through too, but yeah, no, it's working like a regular toilet, and
So
it's using a
there's no
tiny amount of water.
Do you know?
It's still 1.3 gallons per flush, I think, something like that.
And then Daniel has a question.
Hi, Kristin. Thanks so much for presenting about this. I'm very inspired. I actually would love to build my own passive house living home combination someday. So really cool to see that you guys are doing it. The question I had for you is about the insulation. If you're not able to use spray foam, how are you filling in all the little gaps that are inevitably need to be filled in, yeah, towards the end?
Well, you don't need to fill those in if you put exterior insulation on the roof. That's another way to avoid condensation, right? So, that's the code alternative.
Thanks.
It's amazing you did this while it was inhabited. I think everyone is just floored by your work, you guys. Let's see here.
Thank you so much. We did buy a travel trailer and we lived in a trailer over the summer, so next to the house.
And if I missed a question, feel free to chime in because we'll be wrapping up soon. I know there was a little bit of interest in the living building challenge if you were trying to go for all.
I was going to ask about your mechanical room and if you ever came up with a solution for draining condensate and having like a drain penetration there. Just how did you treat the mechanical equipment drains and having a dry trap, saving water, not using a trap primer that uses tons of water, all of that kind of stuff?
Spencer, you can probably answer that better. In the end, we just decided not to put any drain in there, right? Do you remember it?
Yeah, I don't think there ended up being a drain in the mechanical room itself. So the condensate goes to the outside, I believe.
Yeah, it's always something you have to figure out and decide where to put it.
Yeah, definitely.
Cool. You guys did awesome. Great presentation too.
Thanks.
I need to come over.
Thank you.
Wonderful. Someone said you knocked it out of the park. I think that's pretty accurate. So Jay, I think, oh, we have one more. Graham has his hand up.
Yeah, I guess I just want to, for whatever it's worth, put something out there for higher performing windows, domestically sourced. Because in the energy model of this house, even though it's triple pane glazing, and we don't need to get into all that, the US triple pane glazing is lower performing than European glazing, and like that one thing, like turning that knob would have like made the performance much, much higher. But we should just have access to domestic windows and doors that are, of that high performance level. I think it'll be a game changer.
Will you certify the building?
Yes, we are on track with pursuing both certification pathways. Yeah.
Another question. Kristin, your architectural plans were beautiful and extensive, and I wonder if you had any like extra questions from the permitting office, I think a lot of designers kind of get in this habit of providing only the bare minimum to obtain permits, and I, as a mechanical designer, I'm often discouraged from giving too much information because we don't want to raise any questions. So I was just curious if you did get any extra questions. I guess it's a little different from commercial building design, but in residential design, I feel like a lot of people sometimes say like, we don't want to give them anything to wonder about. So just what was your experience there?
Maybe it's because it's Sonoma County, but I think I got 3 plan check comments. And the thing that I was most nervous about was like the vacuum flush toilets, and nothing came back. So, and I don't know, maybe they didn't see it, maybe they didn't care. I doubt that they have seen that before, but no, that was it was our biggest worry before the project, and then it was just no problem at all.
And there is actually a question about that, whether or not they need makeup air or venting in a passive house.
For the vacuum flush toilet, a vacuum flush toilet does not need venting. No, it's that way. It's different from a regular toilet.
And someone asked how inspections went.
It was great. There was the inspectors were interested in what we were doing, and just it was like everybody was part of the team.
Awesome.
One other question. Are you getting certified for the Living Building Challenge as well? And what is the process for that? I think we're more familiar with Passive House than LBC.
For the Living Buildings Challenge, I don't need a certifier. I'm doing that work myself. Like for this, we are working with Steve Mann for getting the certification, the Passive House certification, but for the Living Building Challenge, you just have to provide like tons of documentation. Like the biggest piece is like a material list. Like for each and every material that we use on the project, I need to show where it's coming from, if it's lead free, and so on. There's like 40 columns on this list, and that's something that I would maintain ongoing throughout the project. And then there's like I really need to prove where my waste is going. I need to provide all sorts of narratives about the water, about health and happiness. We need to monitor our air quality, and we need to monitor our water usage. So we need to really prove that we don't need more than 26 gallons per person per day. We need to monitor our energy consumption. But it's the Living Building Challenges, they are extremely wonderful to work with. So they're going to help every project that wants to achieve these goals. They're going to help you through. And if you're not able to meet certain requirements, there's always a way to make up for that.
Fantastic. I think, Jay, are you?
You're on mute.
There you go. We can't hear you. All right. Jay, did you want to share? We can't hear you.
I was muted, unfortunately. So, yes, I'd like to screen share,
Okay.
and hopefully this share comes comes through. Do you see the screen here? The thing here about the key building science enabler?
Yes.
Yeah. All right. Well, then it's affordable. The science enabler to affordable zero net energy, zero net carbon, and healthy indoor air quality is Passive House. And the evidence-based performance based on physics-based modeling and simulation is what's there. It's really building science married with data science is what we're looking for. And the integration of Passive House standards, I'm a big Passive House fan, but I don't say only do Passive House. If you want to do LEED as well, if you want to do well because of the water, if you want to do fit well for you can integrate the Passive House standards. And if you integrate the passive standards with Living Building Challenge or LEED or any of them, the standard that most affordably enables energy efficiency, healthy indoor air quality, and resilience is Passive House. Also, because it's an aggressive reduction of energy consumption and the path to net zero and net zero carbon are more predictable and less risky. And the bottom line is that the integration of Passive House works synergistically with the other standards. And because of the stringent bar that's higher in terms of energy efficiency, healthy indoor air quality, and resilience, you get something that is far better. I did a couple of years ago. I had a person from one of the developing companies in California. They analyzed 11 of their existing buildings, which were LEED built, and then imagined if they had included Passive House for the envelope and air quality that had gone on. They looked at the points, and of the 11, 5 of the buildings that they did jumped from either standard to silver, silver to gold, or gold to platinum, because they got so many points for those things that are there. And the real and it's not true of Living Building Challenge, but of LEED, for example. LEED, if you were putting together a football team, you use a LEED approach, you would get the best possible players at every position, but there's no playbook or game plan. So you may or may not succeed. And so by integrating Passive House with LEED or Living Building Living Building Challenge, it's a great thing to do. So call to action for you, just very quickly. thepassivehouse.cal.org is where we are. If you want to get more involved, you can sign up for the newsletter just by going to the website and signing up. No charge for that. An individual professional membership you can get if you want, or an organization company membership. You could even become a sponsor, donor, or volunteer. Thank you particularly today, Susie, for your driving this, and Kristin and Spencer for speaking, and Graham for the things that you contributed as well.
We will see you all next month.